My name's Mark Weremeyer, and I'm a space domain expert at Cromulence.
My name is John Amin, and I am a software engineer and vulnerability researcher at Cromulence. We are working as hard as we can to make Hackasat 2 as realistic as possible.
So this is the Hackasat FlatSat for this year. So each team will have one of these, and they'll be using them to defend and attack during the game. In traditional space systems, you want to actually build and test something on the ground before you would launch it. So that's sort of what this is, but we've actually also developed it to work for a capture the flag sort of game. But it has a lot of the common subsystems that you would see on an actual small sat or space system. So starting from the bottom, it has a power distribution board that manages basically power through rails on the backside. Moving up, you have the command and data handling board. So that does things like listens for the commands coming in, it manages the telemetry and pushes that telemetry back down to the ground systems. Next up is the attitude determination and control system. And then lastly, for this system, at the top we have the communications board. So that has a USRP B200 radio on the top that we're using to basically receive and listen for radio commands coming from, in the game, what we're calling user segment. And then those commands are basically passed into the rest of the system and can be processed by the FlatSat during the game.
For the FlatSat, we actually created a lot of these boards custom for this game, meaning that every time we press the compile button, it takes several weeks for these boards to actually be manufactured and come into the office. So during that time, we had something called the digital twin, which is a basically perfect emulation of the different components on the actual FlatSat itself, which allows us to test things before we actually even have the hardware. And it also allows us to have varying introspection on each of the subsystems, and it's all virtualized and simulated. So we can pause and step through the system as necessary to either debug or develop for the system. The physical satellite works exactly the same as the digital twin does. It runs the same exact firmware, it runs the same exact processing as well. So on these boards, we have a Spark processor or an ARM processor, and both of those are being emulated as well. So any nuances that the actual system itself, the architecture has, the emulation should also have.
Yeah, we simulate things like the orbits, but we emulate things like the sensors.
Exactly, the hardware and the sensors is what we're emulating. However, the actual physics values are all being ran from a simulation. And that's actually also how the FlatSat is being ran. There is a simulated physics environment that is providing these values over the connection to the hardware itself.
So we found for simulating things like this that it's actually, there's a lot of open source tools available, things like NASA's 42 or tools like AGI's STK, where you basically can use a tool like that to put spacecraft in some sort of simulated orbit, and it will generate things like what is its position, velocity, time vectors. You can also command the spacecraft in simulations like that to turn and point different directions, and then basically generate data for what that simulated spacecraft is and feed that back into a system like our digital twin or the FlatSat so that it actually thinks that it's in those orbits or it's pointing in those directions.
And that's really helpful during this competition specifically because we want all 8 teams to have the same exact environment. And we are hoping that teams leverage that digital twin, especially since last year each team only had one FlatSat, so their entire team all had to share that one single FlatSat. So if somebody wanted to test something, they would have to tell the person that was controlling it, and then they would have to test it. But we're hoping this year they will be able to spread out, and everyone can be testing their own stuff on the digital twin at the same time, so that when they do eventually decide to throw it against the actual FlatSat, it works on the first try.
And just to add to that, there is components outside of the FlatSat itself that are still part of the game. So teams still have their ground station versions, and then we also have something in the game called user segment where we're basically simulating some sort of ground piece that needs to communicate back up to these spacecraft. And those also are chains or pieces within the game that the teams will have to deal with versus just dealing with the FlatSat itself. We're going to work as hard as we can to make Hackasat the most realistic event possible.